Good day. We are now going to try a second gas law problem, and this one's going to be quite a bit more difficult than the first one. So the question is, 174.5 milliliter gas at 32.6 degrees Celsius and 857 torr is chilled and compressed to 794 torr and 152.3 milliliters. Calculate the new temperature in degrees Celsius. So I think the first thing we want to do is go through the problem and identify all our variables. We have 174.5 milliliters. What's that? Yes, it is V1. It's a volume, 174.5 milliliters. Then we have 32.6 degrees Celsius. What's that? You're correct if you said temperature. So 32.6 degrees Celsius is T1. And we have 857 torr. What is torr? It is a pressure, so that is our P1. We have 857 torr. Then we're going to chill and compress to 794 torr. So torr again, it's a pressure. So this is going to be P2. Yes, P2. 794 torr. And we have 152.3 milliliters. Milliliters is a volume, so this is V2. 152.3 milliliters. Again, calculate the new temperature. So T2 is in fact my unknown. Again, the problem is on the back of our periodic table, the equation. We have P1 V1 over T1 equals P2 V2 over T2. Let's write down that equation. P1 V1 over T1 equals P2 V2 over T2. Do we have all three variables in this problem? Yes, we do. We do not have anything skipping today. We have volumes, we have temperatures, and we have pressures. So all three of our variables are involved in this problem. What are we solving for? T2. T2 is what we're solving for. Oh boy, this is down in the denominator. Whoops. So when a variable is in the denominator, you can't solve for it. So we need to get the variable out of the denominator. And so to do that, we need to multiply both sides by T2, which is down in the denominator. Okay, sorry, this is not focusing. So T2 is down in the denominator, and in order to get rid of it, I'm going to multiply both sides by T2. So I'm going to take T2 on both sides. That allows T2 to cancel out. And now T2 is in the numerator on the other side, which is where we want it. So now it's time to isolate T2 and take the P1, V1, and T1 to the other side. So I'm going to divide both sides by V1. This allows V1 to cancel out and takes it to the other side. I'm going to divide both sides by P1. That's going to allow P1 to go to the other side. So P1 canceled out and went to the other side. And finally, I'm going to multiply both sides by T1. That allows T1 to go to the other side. So let's rewrite this because it's a mess. We have T2 equals P2 V2 T1 over V1 and P1. So there is our formula. T2 equals P2 V2 T1 over V1 P1. So now we're ready to plug in. So T2 equals P2 is our first variable, and that is 794 torr. V2 is next, and that's 152.3 milliliters. Then we have T1. Aha! What have we forgotten? That's right, we must change our temperatures to Kelvin by adding 273. So 32.6 plus 273 is 305.6 Kelvin. And then temperature 2 is what I'm going to find. So temperature 1 in Kelvin is 305.6 Kelvin. And now this is all divided by V1, which is 174.5 milliliters, and P1, which is 857 torr. Let's check our units. Torr is going to cancel out. Milliliters is going to cancel out. And that leaves me with Kelvin. Is that the appropriate unit for a temperature? Yes, it is. So now I'm ready to solve for T2. I have 794 times 152.3 times 305.6 divided by 174.5 divided by 857, because it's in the denominator as well. And this equals a long number. Let's pay attention to sig figs. We have 3 as our lowest sig figs. So that's going to be 247. 247 kelvins. That is Kelvin. Now, what did the question ask? It actually asked us to calculate the new temperature in degrees Celsius. So we need to go from 247 Kelvin back to Celsius. How are we going to do that? If you said by subtracting 273, you're correct. Instead of adding, we will subtract 273. So 247 minus 273 gives us a negative 26 degrees. So minus 26 degrees Celsius is our final answer. You may be wondering about the sig figs. Well, remember, when we're subtracting, we go with decimal places. And these numbers do not have a decimal place, so when we subtract, we cannot have a decimal place either. So it actually is just the 2 sig figs now when we subtracted, because there's no decimal places. So minus 26 degrees Celsius is in fact the correct final answer. All right, so to summarize, when you have a gas law problem, you need to go through the problem and identify all your variables. Make sure you put your temperature in Kelvin. Rearrange the P1 V1 over T1 equals P2 V2 over T2 equation to solve for your unknown. Make sure you isolate that variable and then plug in, paying attention to units and making sure your final answer is in fact what they're asking for. So that was our second gas law problem. Thank you very much for staying with me. Have a good day.